Welcome, everybody, to this series of webinars between Manchester Metropolitan University and Enes Juriquilla. My name is Dr. Araida Hidalgo. I am the International Lead for the Department of Life Sciences in the Faculty of Science and Engineering. And today I'm going to introduce this new series regarding engineering, technology, and renewable energies, working along with colleagues from our Department of Engineering. It is my pleasure to help these institutions to work together to make sure that we can build bridges to foster collaborations and to show students what is happening in the other side of the world, either in Mexico or in the UK. Welcome. We hope that you will join us for the 4 weeks that these webinars will be running. And I will now pass to the chair that will host today's webinar. Thank you, Alejandro.
Hello, good morning, good afternoon in Manchester. My name is Alejandro Vargas. I'm currently I'm responsible for the Bachelor in Engineering, Renewable Energies Engineering at Enes Juriquilla in Mexico. And it is my pleasure to moderate and to host this seminar series. And we will start the first talk with Dr. Carl Diver, who is an academic lead on Industry 4.0 and a reader in Industrial Digitalization at Manchester Metropolitan University. Before he got into academia, Carl was working in the manufacturing sector for more than 20 years, first at a large multinational, and then he established his own consultancy. He worked at Delphi Automotive Industries at the R&D department. And in the case of consultancy, he worked for multinationals and SMEs on a range of products. And more recently, Carl has led industry in this 4.0 activity, which we will be talking about, and doing research and teaching for the School of Mechanical, Aerospace and Civil Engineering at the University of Manchester. Between things that he has done, he is working on bringing many technologies together and materials and work closely with businesses in what is called next generation solutions, which include the expertise on artificial intelligence, Internet of Things, big data, analytics, cloud computing. And well, it's my pleasure to welcome Carl. And Carl, let's say the cyberspace is yours to expose what you want to tell us. So we'll be receiving questions from you via YouTube and Facebook Live. So if you have questions, we will have some time at the end of Carl's talk to post them to him and maybe get some answers. If we have too many questions, we'll have to select some, but I hope we have a lot. So thank you, Carl.
Okay. Gracias, Alejandro. Buenos dias, me llamo Carl Diver, and I'm delighted to be here and to have this opportunity to talk to you today. So I'll just try and share my screen. So let me know if that's coming through okay.
Okay.
Oh, we're seeing your other view of PowerPoint.
Oh,
you can switch the. Yes, that's perfect.
Is that better now? Okay, so hi everyone. Yeah, my name's Carl Diver. I'm the academic lead for Industry 4 at Manchester Metropolitan University. As Alejandro said, I'm a reader in Industrial Digitalization, so I'm delighted to have an opportunity to talk to you today about what we do at Manchester Metropolitan University around Industry 4.0. And I'll touch on some of the wider things happening across the UK as well. So what is Industry 4.0? So first industrial revolution was steam, and it really, Manchester is considered the birthplace of that, and that was back in the 1770s. Then fast forward about 100 years and we had electrification, and that was around the 1870s. Many people think it might have been down to the kind of the Ford Motor Company, automotive and that side of things, but it was actually a slaughterhouse in Cincinnati where we kind of first saw some of that electrification coming in. Then another 100 years forward, and we get into the numerical control side of things around the 1970s. And we have these kind of 100-year steps. But we're now in the fourth industrial revolution, and we're probably 50 years ahead of those other 100-year steps. And what is that really about? It's it's about connectivity. It's about digitalization. We all have smartphones. We're all used to connecting on social media, ordering things online and expecting them to be delivered within a couple of hours sometimes, especially during the pandemic. There's been a lot of shift of moving things online, a lot of commercialization of things like that. So it's around digitalization, connectivity, data, accessing that data. But at each of these steps, we saw, the driver for that was improving process efficiencies, resource efficiencies. And I know that some of you on the call today are from studying the renewable side of things and the technology, and both those elements will have a big role to play in Industry 4.0 or harnessing the technology of Industry 4.0. So why is this important? There are lots of facts and figures that are available, and this is just a small snapshot of that, but it could have a $14.2 trillion impact on the global economy by 2030. 67% of UK manufacturers recognize it as an opportunity. And on the back of that, there was a Made Smarter review that was put to government a number of years ago, saying that there was a need for digitalization for SMEs or small medium enterprises, those companies with less than 250 employees, to start to adopt technology, to adopt digital technology to remain competitive. And on the back of that, the UK government has invested somewhere around £150 million with a match coming from industry to help with that kind of productivity increase. So we're seeing, governments, we're seeing companies starting to say there's an opportunity here that we need to do something. This is just a quick snapshot of different countries around the world where organizations realize that there's a gap in the talent gap or a digital gap that they're looking for people with the right skill sets to implement these kind of technologies. And I've also seen, that in Mexico, you've also doing things around Industry 4.0. I think, correct me if I'm wrong, I think something like 98 research centers, and that grew kind of probably exponentially over the last 7 or 8 years. Some kind of clusters that for me are very much in the Industry 4 side of things on, design, big data clusters, intelligent factories, automation, all of that feeding into the Industry 4.0. So it looks like you guys are doing some interesting stuff as well on that. And at Manchester Met, we've adopted our kind of, I suppose our ethos is around bridging the Industry 4 skills gap, linking to industry, speaking to industry, understanding what industry's needs are, and looking at what we're doing from a research and a teaching point of view around what we can do to help bridge that skills gap and bring academia and industry closer together. So many of you, if you're familiar with the Industry 4 term, will probably have come across the 9 pillars of Industry 4 that was coined by Boston Consulting Group quite a number of years ago. Although more recently, I've come across, I think, 17 pillars now, but I didn't have enough space on my slides to get all 17 pillars in there. But and that 17 pillars has been coined by Henrik von Schiele, who's considered the father of Industry 4.0, and he worked with the German government in 2011, 2012 in formulating what Industry 4.0 was about. But these 9 pillars, additive manufacturing, big data, cybersecurity, these are all the kind of terms you'll hear related to Industry 4.0. And when I look across Manchester Met and the university, we're active in these areas. We have a £6 million centre in collaboration with a number of universities in the northwest of England, looking at cybersecurity, working with SMEs and companies in the region for solutions around cybersecurity. We have an advanced materials and surface engineering research centre, again, working closely around the area of additive manufacturing, looking at advanced materials, doing work around food packaging so that you can extend the the shelf life of food products and things like that. And I think I've read that food is one of your big sectors in Mexico as well. And we see that Industry 4 is more than just engineering. It stretches across many sectors. And we have the Manchester Fashion Institute at Manchester Met. And there's some wonderful equipment and activities going on with the Fashion Institute. And Industry 4, you'll also hear very often that it's about personalization and customization of goods, and none more so than where we see opportunities of this in the fashion sector. They've got body scanning technology. They've been doing stuff around with World Rugby, around getting the right fit of the clothes that the rugby players wear. And what we see as well is that our colleagues in the Fashion Institute are working with colleagues in engineering around additive manufacturing and those aspects of that personalization and customization. And our Faculty of Business and Law, we've got the department focused on operations technologies, events, and hospitality. They're doing some interesting stuff around AR and VR, or augmented reality and virtual reality, and also around digital supply chains. There's a real depth of knowledge around logistics and digital supply chains within that group. We have the Center for Advanced Computational Science and the Faculty of Science and Engineering, where I sit, doing some wonderful stuff around AI, big data, and I'll touch on some of that in a while. And we've had a new professor come in to lead on that as well, Professor Yonghong Peng, who's considered a renowned leading researcher and academic in the area of AI, and leading into AI in healthcare as well. And it's that, again, multidisciplinary nature of Industry 4 and digitalization that it touches so many different sectors. For the people who are interested in the renewable side of things, we have the Manchester Fuel Cell Innovation Centre. It was established 3 or 4 years ago, £4 million investment, supporting companies in the region looking at fuel cell technology, and in particular hydrogen fuel cell technology. We have the Institute of Coding, which is part of a wider network across the UK, looking at bringing digital technologies and digital skills into many different sectors, and that also includes banking and sectors such as that. We have the Future Economies Research Centre, and it's important that we look at the economic impact of this side of things as well. So they're doing interesting studies around the economic impact around Industry 4, the impact around healthcare, if we're getting into that side of things. So we work closely with our colleagues there. And then we have Print City, which is our 3D printing facility at the university. And it's quite a unique facility. We have over 70 printers now. It was established 3 years ago. It's grown exponentially. We have 8 different technologies. And it's a center that is open not just for students from engineering, but we have students from, like I said, the Fashion Institute, from architecture, from business and law, from music, all coming into this space and being created. And we established an MSc in Industrial Digitalization, one of the first of its kind, about 3 years ago, and bringing and allowing students from different backgrounds to come and study around industrial digitalization, around additive manufacturing. And one of the interesting things with that course is that we saw in the first 2 years nearly a 50-50 split between male and female, which is kind of unheard of in some of these kind of more maybe traditional engineering courses. So we're quite proud of that fact. And it's an open space, it's a creative space, and I guess industrial engagement is quite a strong element of what we do. And we work quite closely with Autodesk. It's a San Francisco-based 3D design. They create 3D models. So we work quite closely with Autodesk as well, and have access to their generative design packages as well for that kind of design optimization, topological optimization. So some really interesting stuff. And if you want to look at our website and look at Print City, you'll see some of the interesting things going on there. Some of our students on that course also have their own kind of bios, their own area on that site, so you can see some of the projects that they're working on. I mentioned the Center for CFAX, the Advanced Computational Science. My colleague, Professor Han, pictured here. has been doing some really interesting work around applying AI in the area of farming. And this is a project, if you're interested, I think you can download the app. It's called Agri1. It's looking at detecting disease in crops. So you have the drone flying over the crops, taking images, and then AI is looking for any issues around potential disease, and it allows the farmers then to implement and intervene. So an interesting application of AI. And one of the things, and kind of my job at the university, I've the very privileged opportunity to be able to work with colleagues in the different faculties who are involved in digital technology, digital research. So about a year and a half ago, we ran a sandpit between the Faculty of Business and Law and Science and Engineering to bring those academics and colleagues working around digital technologies together. And one of the projects that's grown out of that, and we actually just submitted a proposal yesterday for funding in the UK around applying AI in healthcare. But we had colleagues from health science, from computer science, from business school, from engineering involved in this project. So I'm going to play this short video. I hope it plays.
Live 4.0 is an ambitious project which brings together an interdisciplinary group of researchers, stakeholders, GPs, and patients with two streams of work. One stream being to create an AI algorithm to better predict the risk of cardiovascular disease, and the other stream being working with those stakeholders, GPs and patients, to develop a way for this to be used in practice and make the most difference.
Medical practitioners are guided by risk algorithm for CVD prediction, mainly based on limited variables across a homogeneous population, which do not assess the impact of an individual patient's unique set of risk factors.
This is a really exciting project that's bringing together experts from across the university, experts in the Northern Care Alliance, the Salford CCG, and patient representatives, where we'll look at digital technologies such as artificial intelligence, harnessing data that exists, historical data that exists around cardiovascular disease.
The Salford dataset is a really important dataset. It spans 18 to 20 years worth of data from the GPs, but also from hospitals. And as such, it's fairly unique within the UK. There's only a couple of other places like it. But we believe that it holds great promise because within that dataset, there are likely to be novel signatures that indicate someone's at risk of a heart attack.
Working with GPs, healthcare professionals and patients throughout the project is absolutely central to what we're trying to do. It's really important that we don't create something in isolation and that it's usable and practical for those around us.
I think it's really important that people get involved in these kind of opportunities because they really do have the chance to make a difference. And I think by getting people involved in these kind of activities, then they can make suggestions, they can get their thoughts and their ideas heard and ultimately make a difference to the outcomes of that research.
For the future of the project, I hope that we can create a sustainable group of both academics, stakeholders, patients and GPs to create a real difference and go forward with this project and beyond.
The project has the potential to result in an extension of healthy life expectancy for many individuals. This will allow people to work and contribute to society for longer. It will reduce the burden on the NHS and will enable people to spend more quality time with their loved ones.
So what I really like about this is those different elements and sectors and specialisms coming together, and it's using this technology for good and for the benefit of our wider population. So we're really excited about this project and the bigger vision that we have of where that can go. So, and again, I guess Industry 4 is this, multidisciplinary approach. And I mentioned the MSc in Industrial Digitalization. These are 3 students that I supervised a number of years ago in the first cohort of this Industrial Digitalization Msc. One was from a business background, the other 2 had a kind of a product design background, and we were working with a well-known footwear brand, looking at kind of the design of shoes. So we needed to look at 3D scanning technologies. We needed to embed smart sensors, and then we looked at the design and the topological optimization using generative design. But we pulled in other experts across the university as well, so sports psychologists, physiotherapists, and also worked with our colleagues in the kind of biomechanics side of things, looking at gait analysis and pressure sensors on the floor in the gait analysis, looking at how people were loading on the footwear as they were stepping down and moving around. So it's bringing all of those things together, sharing of that technology, and then using the technology to come up with solutions. This was the start of the project, top left. As I said, it grew by quite a lot, and we pulled in other colleagues and experts from across the university. So a very successful project. And kind of building on the strength of that, that got us into looking at more around footwear and kind of supply chains. And we're currently working on as part of a wider consortium to put together a proposal. We've been successful in the first stage. We'll be submitting a proposal by the end of this month to form a UK digital supply chain hub. And at Manchester Met, we're going to be looking at the supply chain side and the textile side of things. But other companies involved are the likes of Accenture, Google, Siemens, and others. So it's a very exciting project looking at all elements of the supply chain. I also sit on the Industrial Advisory Board, or I'm the chair of the Industrial Advisory Board in the Department of Engineering. And I think it's that element again of that strong link with industry and understanding what industry's needs are, and having that element of collaboration. So we've got a very vibrant Industrial Advisory Board, over 40 members from micro enterprises to large multinationals. And this January, we ran a employability week for our students. We had over 15 companies involved. It was all done virtually. The companies set challenges. The students worked in multidisciplinary groups to address those challenges in a 24-hour period, and then kind of pitched back the next day. I think there were over 75 sessions run that week, and the whole event was opened by Carl Ennis, who's Siemens CEO for UK and Ireland. And I want to play this short snippet from his talk at the launch.
Give the best day work that you can. And absolutely don't leave anything on the sideline. Absolutely give it. And by the way, if you're not enthusiastic about the role that you're doing, such that you want to give it your best, go and do something else, because life's too short, right? So this isn't, really give it your best. When you do that, you will be noticed, right? People see that. They see people who deliver on their promises, who do excellent quality work, and they get opportunities asked. And then my second guidance is, when you get those opportunities, grasp them. Because even if you don't think you can do that, somebody else thinks you can, and they're probably right.
And that message resonated with a lot of our students, but also the opportunities that our students had to develop the skill sets around Industry 4. And during that week, we saw some of those students gain that opportunity through the skill sets that they have. We have strong links with Siemens. We work part of an initiative called Connected Curriculum, and we're looking at, it gives us access to Siemens software and hardware, and also training material. We're at the start of that journey, but we're looking at how we embed that into some of our courses, such as the MSc courses on the right-hand side. And actually this week, we've just launched for our second year students a project based on the UK Ventilator Challenge, which saw a large number of companies coming together last year to start the ramp up of ventilator production. Our students now are working with some of the technologies that were used in that challenge. So it keeps it relevant, but they're also getting those skill sets embedded. The other side, I've touched on the Cyber Foundry. We've got the AI Foundry that was recently funded, I think 4 million in funding, again, supporting SMEs in the region around AI. We've also just secured funding of around 3.2 million to establish Print City Network, which is building on the focus of Print City, but an area dedicated for SMEs to be able to come in and engage with additive manufacturing technology. All of this also has to tie into sustainability, and that's very much core and a strategy within Manchester Met. These are an example of some European projects that we're involved in. Surmap's looking at taking recycled concrete, using that as from an additive manufacturing point of view, looking at creating street furniture initially, but it'll help develop the technology in years to come to have other applications. Transform CE is a project looking at taking domestic plastic waste and using that as a feedstock for additive. And Share Repair is one that's looking at consumer electronics and the repair side of that. Knowledge transfer partnerships is an area that we're very strong in, and it's funding that comes through the UK government to help industry and universities work together with students or recent graduates working in the company, bringing technology from the university and embedding it in companies. We're consistently in the top 5 in the UK with a number of knowledge transfer partnerships running. And these are some of the stats around the impact that it's had on the university and in businesses. We believe in getting our students out and meeting with industry. And before the pandemic, about a year and a half ago or 2 years ago now, we were part of an Industry 4 trade show that was held in central Manchester. Top left, you can see a stand that was dedicated to our students, and they were able to display the work that they had. Top right, you see some of our students on the main stage talking about their experiences around digital technologies. And I think with that, I'll just leave this video playing. And it's just a snapshot of what that show was like. But we had over 70 members of staff involved over 2 days, and from all, I suppose, faculties and different departments across the university. It was a real opportunity to showcase some of the great stuff that's happening across the university that is related to Industry 4.0. So with that, I would like to say thank you, gracias. It's been a pleasure. And if there are any questions, I'm happy to take them.
Thank you very much, Carl. It was a very interesting talk. We have, for the time being, we have no questions from Facebook or YouTube, but I have a question. So if I may ask one. If I understand correctly, Industry 4.0 is all about communication. You know? So communicating, well, it's not all about that, but has to do a lot with communication, with communicating within the manufacturing process, that all the parts are kind of working together in harmony, let's say. And I've always wondered how resilient is this industry being made, because what happens when there is failure? Is this of some critical component? I mean,
so do you mean failure from a maintenance point of view, or do you mean failure in capturing the data?
Yeah, for example, in capturing the data, or in let's say a critical component fails, and then that is critical so that you cannot continue the process in what you had planned in some way. Yeah. So is there research being done on this issue?
So I think there is on resilience. I guess there are issues around, your, I suppose, how secure your networks are and how resilient, your data transfer is. So there are challenges around that, and making sure that those systems don't fail. I think you also have issues around how well your components are going to actually function when they're in operation. I suppose one opportunity around that is the side of additive, and I actually had some conversations with some large multinationals yesterday around issues that they have around if something breaks on the shop floor or on their production line. Waiting to get parts from an OEM, and we've had a number of companies looking at opportunity of having their own 3D printing facility, so they can print spare parts on site, on demand when they need it, to help them get over that ramp of waiting for maybe the specific part to come from the OEM. So, so there's an opportunity, I guess, to harness the technology in that way, and that then develops some of the skills of the workers on the shop floor, because there are challenges around that, getting some of the CAD skills in place that allows them to be able to design that fixture that they might need to be able to kind of keep running. So.
Great, thank you. We have 2 more questions from the audience. So one is from a student. So he says, do you think at least some degree of knowledge in data analysis or digitalization of any kind is needed despite your area of expertise? So how important it is to know about data analytics and digitalization?
I think there are elements of that. So I suppose a good example is one of my PhD students. He was a mechanical engineer, and he moved on to do, so he was an undergraduate, he moved on to do his PhD with me around electrochemical machining, which is kind of one of the processes I used to work in automotive. But we saw the requirement to be able to capture data, get it on the cloud, being able to visualize that data for different people, because we're developing a kind of a machine that would be potentially used for commercialization. So even as a design engineer and a mechanical engineer, you had to develop some of the skill sets around kind of cloud computing, being able to connect. So we were using things like Arduino, open source platforms, Node-RED programming, I guess. So not getting into detailed programming, but that kind of flow programming side of things. So there's a lot out there that you can kind of self-train as well. So you don't need to be an expert in it, but I would say that you're an expert in one area, but you have to probably gather knowledge in other areas that you can do some, maybe the low level side of things. But you definitely need, I would say, as we're moving forward, to have that flexibility and adaptability and to be open to learning skill sets in other disciplines.
Okay. We have maybe one last question, because otherwise we will be running out of time. So Dr. Giordano asks us, I wonder how is the relation between industry and the university to understand the current needs and inform curricula working for you? How much have your curricula changed based on this relationship between industry and academia?
So I suppose a perfect example of that is the Industrial Digitalization Msc. So that came about from looking at what was in the Made Smarter report that went to government. As that unit was, or that course was being developed, industry was brought in to talk to them. So we had a wide range of, I suppose, different sectors telling us what their needs were, and that course was developed around that. And with the other MSc programs, we're having conversations also with the likes of Siemens around, what are the things we're looking at. There are areas we need to make sure that obviously some of the course elements are delivered, but we need to look at some of the soft skills as well. And so at the moment, there's a lot happening around maybe the soft skill side of things. So you go for an interview, you're asked about some of the academic side, but very often you're also asked about other skill sets that you've developed. And one of the things we're trying to do on that side with our industrial advisory board is running the things like employability week, where you develop some of the other skill sets of that teamwork and working under a tight timeline with people you may not have worked with before. So it's going well, and we're seeing, I guess, we're really enthusiastic about the willingness of industry to give up time and to come in and to work with us. And I think we've been blown away actually by the willingness of industry to do that. So it's working really well.
Great. So it's good that you tell us that, because that's showing us that somehow NS is going in the right path, the right direction. Also fostering these soft skills on students.
I think the other point to add to that is, from an accreditation point of view, our accrediting bodies have been impressed by how we're engaging with industry as well, and it's really helped another kind of string to our bow, I guess, around accreditation of our courses.
Okay, great. Well, time has gone very quickly, so we have to prepare ourselves for our next speaker. So we thank you, Carl, with a thank you for your talk. It was very, very interesting. We have some other questions, but I guess we don't have now time but maybe we can send them to you, and in that case, and you can
yes,
answer them directly.
Feel free
to
pass on my details.
Okay, thank you. So let me then introduce our next speaker. The next speaker is Dr. Alejandro Franco Pina. He's currently a professor at Enes Juriquilla. He has He was just starting as a professor at ENES last October, so he's one of our new, let's say, professors at the university. He got the degree in a doctor in engineering in 2017, and he's a member of the Sistema Nacional de Investigadores, of the National System of Researchers. He has more than 6 years of experience in teaching and in research in the areas of mechatronics and renewable energy, advanced electronics, simulation, among others. And he was working first with CIDESI, with a center here in Querétaro, working on some robotic prototypes. And then he started working on wind engineering, so wind systems and renewable energy from wind. And as he did a stay at the Technical University of Berlin in working on smart blades for generators, for wind generators. And so he will talk to you about his current research interest, and so I welcome then Professor Franco. Thank you, Alejandro.
Hello, everybody. I try to share the presentation. Let me second.
Perfect.
It's okay?
Yes, perfect.
Okay. Well, hello, everybody. First of all, I would like to thank you for the invitation to this important binational seminar. In this presentation, we are going to talk about a new diffuser model for wind turbines, as well as the evaluation of its performance. And the content of the work will be divided into 5 sections. First, I will give you a background on the technology behind diffusers. After this, we will present the proposed methodology to carry out this study and its future experimental validation. And then we will present the results obtained to date and the conclusions. And this conclusion allows us to continue studying future models of diffusers. Finally, I will present you the future work plan. Well, wind energy is currently considered as one of the most important technologies for electricity generation, especially when we take into consideration economic and environmental circumstances. The wind power industry is an edge of substantial growth as a result of advances in different areas of technology. Adding to this, we have the problem about the environmental pollution, and this problem have made urgent the need to increase the performance of the wind turbines. What about diffusers? Well, diffuser augmented wind turbines, or its acronym D8WT, have been proposed by numerous scientists as a way of achieving this power increase. In Figure 1, we can see the difference in the output performance between a small wind turbine with a diffuser at the same turbine, but without it. It's easy to see the path that is achieved, and the power could increase up to 4 times. And this phenomenon behind this increase is the diffuser. The diffuser creates a negative pressure zone downwind of the turbine that increases the air mass flow through the blades of the turbine, thus increasing the power output. Nowadays, there are mainly three types of diffusers. First one is the conical diffuser, are the simplest kind of diffuser as they depend only on the length of the wall and its angle. While flange diffuser are the most complex due to having more parameters such of the wall shape, its angle, each others. And we are gonna have a special type of diffusers. They called Airfall Diffuser, are of a great interest to the researchers because there is a wide variety of airfalls, and the other is that there is a lot of information available publicly about airfall performance and its aerodynamic performance under different wind conditions. And what does it make interesting to the airfall diffusers? Well, first, a higher aerodynamic performance. This is the relation between CL and CD coefficient. This relation will result in a larger mass flow augmentation ratio when an airfall is used as diffuser geometry. So there are a lot of airfall diffusers for long wind speed conditions. But a special type of these devices are the blunt trailing edge airfalls. In figure 3, we can see a blunt trailing edge. It looks like the trailing edge was cutted. So this is the shape of the blunt trailing edge. This study, for this reason, this study presents the evaluation of a novel diffuser based on a blunt trailing edge using CFD simulation and an experimental validation method proposal. Let's continue. In this slide, we got the methodology represented by this diagram. This is divided by two main stages. We can see in the blue square the first stage that includes airfall validation, angle selection, model implementation, CFD simulation, and these activities let us obtain a diffuser performance comparisons. And the F300 is our promising diffuser, so we need validate through experimental results. For this, second stage is going to be important, and it's also important to say that these activities are running right now. So this integrates diffuser manufacturing, the selection of the instrumentation strategy. As a future work, we're going to have wind tunnel testing, and finally, we will have diffuser the diffuser experimental validation. Okay, so for the first step is the airfall validation and angle selection. And this author created a new airfall in the year of 2012. And this new airfall profile was created by increasing the trailing edge of the S1210 airfall by 3% of the chord. The results showed that this airfall outperforms the CL-CD ratio of other low-speed airfalls while delaying the stall angle. So it was born the AF300 airfall. Also, it's important to say that the airfall used in this study were the S1210 and S1223. These airfall were gathered from the available literature for being identified as the best performing long wind speed airfalls. Well, the angle of attack for the transversal section of the diffuser was selected based on the parameters that give the best performance results in studies made by other authors. There are two design parameters. One is a good relation between the diameter D of the turbine and the height of the diffusers. We can see the parameters here in the figure 6. Another one is the length of the diffuser L in relation with the diameter of the wind turbine. After this, in this study, a model was performed to maintain the horizontal lengths constant with varying both the angle of attack and the chord length until the desired HD and LD ratios were met. The resulting angles, we have the resulting angles here in the slide for the 3 different diffusers. So, in the model and CFD implementation, and we implemented the actuator disc model to account for the wind turbine diffuser system, the interaction between a wind turbine, the simulation of a wind turbine, and the diffuser system. The complete theory of the actuator disc model can be found in this reference, so we don't talk about this model. And the implementation was performed in ANSYS Flint. The flow, this equation relates the pressure, differential pressure, and the thickness of the media of the fluid. With this model, we implemented the CFD simulation. CFD is computational fluid dynamics. So computational simulation with a full flow solver were implemented in order to analyze the flow and the aerodynamic performance of the wind turbine diffuser systems. In figure 7, we can see the mesh refinement for the porous zone or the actuator disc. And we can see the small elements around the diffuser. As a result, the aerodynamic performance comparison was performed between the 3 diffusers for a low Reynolds. The performance comparison was developed using the software Kubelet. Kubelet is a software developed by the Technical University of Berlin. It's an open source software. So if you want to prove this software, it's gonna be great if you download it for free. And this software implements the panel method used in Xflow. So we could obtain the differential of lift coefficients and the relation with the Gibbs coefficient for different degrees for the 3 different airfoils. So according to these figures, it can be evidently seen that the AF 300 show a better aerodynamic performance compared with the other 2 airfoils. So after this, and for made qualitatively comparison, we obtain this 3 images of the flow around the 3 different diffusers. So figure 10 shows the flow close to the section between the diffuser and the actuator disc. It's important to infer that the flow, well, first we need to see and identify that the flow separation zone is weaker for the AF 300 diffuser. And it's important to infer for this that less energy is lost due to the viscous effects in the wake behind of the diffuser. And for this, according to this, more available energy can be harnessed by the wind turbine. So finally, as a simulation result, we have the table 1. That is the results of comparison of the performance of the 3 diffusers models that was evaluated by calculating the increment of the kinetic energy. In figure 11, we have the comparison in the wind velocity profile. It's evident that the red line have an increment in the wind velocity, and also it will provocate better performance in the wind turbine that is using this type of diffuser. So in the table 1, we see the values, and we have a significant increment in the percentage of the augmentation by about 7% in comparison with the other 2 diffusers. Well, in this slide, we are seeing the working process and the expected results. We have the manufacture, sorry. We have the manufacture process, and we are suggesting 2 methods for the manufacture of these diffusers. First one is the 3D printing with a subsequent surface finishing, and the other one is vacuum infusion with fiberglass. And this second process will be required collaboration with the Autonomous University of Querétaro. So it's important, it's an important step for the manufacturing of the diffusers. The other one is the selection of a good or adequate instrumentation strategy. First, is required the selection of the sensors with microelectromechanical systems technology. These sensors allow us to embed the sensors into the surface of the diffusers to measure the pressure profile. That is important because these MEMS don't interfere with the free flow wind. So this pressure data will be compared with the simulation data for validation. And on the other hand, we got a wind velocity measurement for different radial location inside the diffuser geometry. This measurement will be relevant to verify the velocity augmentation inside the diffuser. Okay. Well, as a conclusion, this work identified a promising bloom trailing edge airfoil for improving the performance of dots. In a comparative simulation study of the aerodynamic performance under low Reynolds number condition, the AF300 airfoil presented better aerodynamic efficiency and a higher CL coefficient compared with the other diffusers. So table 1 shows an increment in the energy captured in the dot system of the 49% with respect to the actuator disk without diffusers. It was identified that it is essential to select an adequate manufacturing process and to develop a robust instrumentation and data acquisition system for future wind tunnel tests. Also, the conclusion is that experimental validation strategy of diffuser model will be based on the analysis and comparison of the data obtained through the wind tunnel test and the simulation results. The results presented in this work open a new line of research exploring different geometries for bloom trailing edge airfoil, especially designed for DOTS application. DOTS, I told you, is diffuser augmented wind turbines. So finally, as future work, we will need to implement the wind tunnel test. We have 2 alternatives: the lab air equipment that it will be installed in NS UNAM, and also the wind tunnel in Instituto Tecnológico de la Laguna, and it will depend on the availability. So Okay, we have the references, and well, thank you for your attention. And anybody have a question?
Yes, thank you, Alejandro. We have at least one question for. Oh no, it's sorry. It's a question for that was answering a question from the last presentation. I do have one question regarding these air diffuser systems, and it's the increase in let's say in performance is around 50% more. But how are these diffuser systems relate to the increased cost of manufacturing and the increased cost of operation and maybe of installation and the weight and things like that in a wind turbine? How do they add up?
Well, it's a good question. And also in this slide, talk about, for example, the manufacturing of a diffuser with a trailing edge. The trailing edge is a sharp trailing edge. Is really complicated. So this is a new alternative for this manufacturing process that is hard to carry out. So this increased the cost of the wind turbine but another important thing is these diffusers are implemented in small wind turbines. And the reason is that the turbulence that we will find in an example in buildings or cities. We know that the small wind turbine are designed by environment inside of the city or in isolated or remote places. So I think that the increase in the performance of the wind turbine is more relevant than the cost of the manufacture of the diffuser.
Okay, thank you. I think this was a very interesting talk following the talk on Industry 4.0, because I think in some sense, Industry 4.0 will have or should have a big impact on the manufacturing processes of these wind turbines. So you talked about additive manufacturing, for example, for designing the diffuser and things like that. So well, I don't know if you can comment a little bit on that, just to finish.
Yeah, obviously, I think that it will be an important thing that the additive manufacturing in these prototypes. And also we have the infusion and other types of process of manufacturing, example of the carbon fiber and fiberglass.
Okay, well, thank you, Alejandro, for such an interesting talk. So maybe we should also put applause to Alejandro. And well, time has gone by very, very quickly. So I think we have met the expectations, and this has been a very nice seminar. I don't know if anybody from the other side would have final remarks, or we can just finish here. Well, we invite you, by the way, to the next talk. Remember that this is a series that will be happening every Thursday at the same time. So this month we will have talks on basically from the NS side on renewable energy engineering and technology and the technology bachelor. So we hope to see you also next Thursday. So thank you.
Thank you, everyone. Thank you, Alejandro.
Bye-bye.
Pleasure.
Nice meeting you. Oh, thank you for